One of the great rewards of studying chemistry is to become a good problem solver. Being able to solve complex problems is a talent that will serve you in all walks of life. It is our purpose in this text to help you to solve problems in a flexible, creative way based on understanding the fundamental ideas of chemistry. We call this approach conceptual problem solving. The ultimate goal is to be able to solve new problems, that is, problems you have not seen before on your own. In this text, we will provide problems and offer solutions by explaining how to think about the problems. While the answers to these problems are important, it is perhaps even more important to understand the process, the thinking necessary to get the answer. Although at first we will be solving the problem for you, do not take a passive role. While studying the solution, it is crucial that you interactively think through the problem with us. Do not skip the discussion and jump to the answer. Usually the solution will involve asking a series of questions, making sure that you understand each step of the process. This active approach should apply to problems outside of chemistry as well. For example, imagine riding with someone in a car to an unfamiliar destination. If your goal is simply to have the other person get you to that destination, you'll probably not pay much attention to how you got there. And if you have to find that same place in the future on your own, you probably will not be able to do it. If, however, your goal is to learn how to get there, you would not be able to do it. You would pay attention to distances, signs, and turns. That is how you should read the solutions in the text and in the text in general. While actively studying our solutions to problems is helpful, at some point you will need to know how to think through these problems on your own. If we help you too much as you solve these problems, you won't really learn efficiently. If we always drive, you won't interact as meaningfully with the material. Eventually, you need to learn to drive yourself. We will provide more help at the beginning of the text and less as we proceed to later chapters. There are two fundamentally different ways you might use to approach a problem. One way to emphasize memorization, we might call this the pigeonholing method. In this approach, the first step is to label the problem to decide in which pigeonhole it fits. The pigeonholing method requires that we provide you with a set of steps that you memorize and store in the appropriate slot for each different problem you encounter. The difficulty of this method is that it requires a new pigeonhole each time a problem is changed by even a small amount. Consider the driving analogy again. Suppose you have memorized how to drive from your house to the grocery store. Do you know how to drive back from the grocery store to your house? Not necessarily. If you have only memorized the directions and do not understand fundamental principles, such as I traveled north to get to the store, so my house is south of the store, you may find yourself stranded. In a more complicated example, suppose you know how to get from your house to the store and from your house to the library. Can you get from the library to the store without having to go back home? Probably not if you have only memorized directions and you do not have a big picture of where your house, the store, and the library are relative to one another. The second approach is conceptual problem solving, in which we will get the big picture, a real understanding of the situation. This approach to problem solving looks within the problem for a solution. In this method, we assume that the problem is a new one, and we let the problem guide us as we solve it. In this approach, we ask a series of questions as we proceed and use our knowledge of fundamental principles to answer these questions. Learning this approach requires some patience, but the reward for learning to solve problems this way is that we become an effective solver of any new problem that confronts us in daily life or in our work in the field. In summary, instead of looking outside the problem for a memorized solution, we will look inside the problem and let the problem help us as we proceed to a solution. As we have seen in problems, we have already considered that there are several organization principles to help you become a creative problem solver. Although we have been using these ideas in earlier problems, let's review and expand on them, because as we progress in our study of chemistry, the problems become more complicated, and we will need to rely on this approach even more. Using a conceptual approach to problem solving will enable you to develop real confidence in problem solving. You will no longer panic when you see a problem that is different in some way from those you have solved in the past, although you might be frustrated at times as you learn this method. We guarantee it will pay dividends later and should make your experience with chemistry a positive one that will prepare you for any career you choose. To summarize, one of our major goals in this text is to help you become a creative problem solver. We will do this by at first giving you lots of guidance on how to solve problems we will derive, and we will hope you be paying attention instead of just riding along. As we move forward, we will gradually shift more of the responsibility to you. As you gain confidence and letting the problem guide you, you will be amazed at how effectively you can be at solving complex problems, just like the ones we will confront in real life.